In this video, we're going to do several examples where we practice finding the form of the particular solution, yp, in the method of undetermined coefficients. So find the form of yp. So let's look at some examples. So A. So we're given the complementary function. So this is the solution to the homogeneous differential equation. Say c1e to the negative x plus c2e to the negative 2x. Okay? And then we're given the right-hand side of the dE, which I'll call g of x. So g of x is equal to 10. So this here is the right-hand side of your dE. That's what you'll see on the right-hand side. The question is to find the form of yp. So how I do it is I do it in steps. So I make an initial guess, and the initial guess is based only on the right-hand side. So based on the right-hand side, the initial guess is that the solution should have the form of a constant. So yp should be equal to a. So then I do a modified guess. So now you only look at the initial and you look at the terms of yc. And if there's repetition, then you multiply by x. In this case, there's no repetition. These are all exponential functions. This is a constant. So the modified guess is equal to a. So that's the form of yp. Let's do another one, b. What if we had y sub c equals c1 plus c2 e to the x? That would be the complementary solution, right? That's the solution to the homogeneous equation. And now our right-hand side of our dE, in this case, is negative 3. So again, the first thing you do here is you only look at the right-hand side of the dE, which we're calling g. So to make our initial guess, it's going to be the same as before, right? Because it's a constant. So yp is equal to a constant. So now for the modified, we have to look at the terms of yc. So in this case, we have a here. And look, here we have c1. There is repetition. So we have to multiply this by x to eliminate the repetition. So yp is equal to ax. And then there's no repetition here, so life is good. So that would be the modified. So again, you first look at the right-hand side of the dE and nothing else. That gives you this. Then you look to see for repetition, right? If there's any repetition, you have to multiply by x to get rid of it. Let's do another one, c. Just keep doing these. So yc is equal to c1 e to the negative 4x plus c2x e to the negative 4x. That's our complementary function. And here we have g of x. This will be the right-hand side of our differential equation. So 9 plus e to the negative 4x. Let's try that one. All right, so as before, we'll make our initial guess. And when you make the initial guess, you only look at the right-hand side of the dE. So initial. So we're only looking at this, okay? So yp. Now, these are two different things, right? And they're separated by a plus sign. So it's like we're making two initial guesses. So for example, for the 9, our initial guess is going to be the constant a. And then for the e part, that's going to be plus b e to the negative 4x. Okay, so it's like two separate guesses. Now we'll do the modified. So when you're doing the modified, you just carefully look. So you do one at a time. Because it was two separate guesses, we have to do it twice. So we look at a. Is the repetition? Nope. Is the repetition? Nope. So a is good. So a stays the same for the modified. Now we look at this one. Is the repetition? Yes, yes there is. So then we would have to multiply this by x, right? So we would get bx e to the negative 4x. But look, there's still repetition. So you got to multiply it by x again. So you're going to get bx squared e to the negative 4x. Pretty tricky stuff. Right? Pretty tricky stuff. So again, you see the repetition here with this one. So you multiply it by x. But that's not enough because there's an x here. So you actually need an x squared. Right? You need an x squared. So that would be the form of yp, which is the particular solution. Let's do another one. Let's just keep going. D. How about this one? Y sub c is equal to c1 cosine x plus c2 sine x. Okay, that's the homogeneous solution, if you want to call it that, or the complementary function or a complementary solution. And the right-hand side of our DE is 3 plus sine x. So as before, the very first step, right, is you look at the right-hand side of your DE, which is g. Okay, based off that, we have two guesses again. We have a constant for the 3. And whenever you have a sign, you have to have a sine and cosine. So we'll do plus b sine x plus c cosine x. Okay, so if you had a cosine, it would be the same, right? It would be the same. So they always come in pairs. That's our initial. So now we'll do our modified. So we had two separate guesses. We had one for the 3 and one for the sine. So let's do a first. So no repetition there. So life is good. We have the a. But now look, we have repetition between the sines and cosines. So we have to multiply the whole thing, this whole thing by x. So it'll be plus bx sine x plus cx cosine x. Right, multiplying the whole thing by x, right, because there's repetition on the entire thing. Okay, so that would be the modified in this case. Let's do another one. A, B, C, D, E. How about this one? Y sub c equals c1 plus c2x plus c3 e to the 6x. That would be the complementary function. Okay, that's the complementary function. And in this case, g of x is equal to 2 minus cosine x. All right, so as before, we'll do our initial. And when you're doing the initial, again, you only look at this one here, right? You only look at this one here. So based on the initial, the 2 is going to give us an a. And because we have a cosine, that means we need to have a cosine and a sine. Now there's a minus, but you can just do plus, right? Because remember, constants can be negative. So b cosine x plus c sine x. And you could have put the sine first. It doesn't really matter. Now for the modified, we only look at yp and the terms of yc. So look at this. Ooh, repetition. So we need ax. Oh, but look, repetition. So we need ax squared. So we have yp equals ax squared. And then nothing else repeats, right? The a does not repeat with the e, and these cosines and sines don't conflict. So they stay the same. So b cosine x plus c sine x. So that would be the modified guess. Let's do another one. A, B, C, D, E, F. How about this one? Y equals c1 cosine x plus c2 sine x plus c3x cosine x plus c4 x sine x. That's our y sub c. And then the right-hand side of our DE is g of x equals parentheses x minus 1 quantity squared. All right, as before, we always look at the initial first, at g first, sorry, to do our initial guess. So you can think of this as x squared minus 2x plus 1. That's what you would get if you would multiply this out. So your initial guess is just a quadratic. It's ax squared plus bx plus c. And if you look at the quadratic and then you look at the terms of yc, there's no conflict, right? There's no repetition at all. So the modified is exactly the same. So the modified would be ax squared plus bx plus c. So not everything is hard. That was a nice, simple problem. G, let's do another one. How about this one? Y sub c is equal to c1 plus c2 e to the 5x. And then our g of x in this case is 4 plus e to the 5x. Okay, 4 plus e to the 5x. So in this case, we'll do our initial. So initial. And when you're doing the initial, you only look at the right-hand side of the DE. So the 4 is going to give us a constant, so a. And this exponential function is going to give us plus b e to the 5x. So now we'll do the modified. And when you do the modified, you look at your initial and you look at the terms of yc. So a repeats with this one, but not with this one. So we have ax. And then this one repeats only with this one, so we have to put an x on that one too. So c2x, sorry, bx e to the 5x, right? We're putting the x here. All right, so there's our modified. Let's do another one. A, B, C, D, E, F, G, H. How about this one? Y sub c equals c sub 1 cosine 3x plus c sub 2 sine 3x. Okay, 3x. And g of x in this case is going to be e to the 8x. Okay, e to the 8x. That's the right-hand side of our dE. So our initial in this case is based solely on the right-hand side of the dE, which is this. So it's going to be yp equals a e to the 8x. Then you look at this and you look at the terms of yc. There's no repetition. So our modified is exactly the same. So yp is a e to the 8x. Let's do another one. A, B, C, D, E, F, G, H, I. Let's keep going. I. This one looks like it's a bit harder. Y sub c equals c1. Okay, c1 e to the x plus c2. Okay, c2 e to the negative x. Okay, e to the negative x. And g of x in this case is x cubed e to the x. Interesting. Okay. So the initial this time, okay, is based solely on the right-hand side of the dE. This is a cubic, so you need to have a full cubic in your guess. So ax cubed plus bx squared plus cx plus d, okay, e to the x. That's our initial. So now we'll do our modified, and we need to see if there's repetition. Okay, we need to see if there's repetition. You might say, well, this is a cubic, there's no repetition, but no, yes there is. Look, d e to the x repeats with c1 e to the x. So we have to multiply the whole thing by x. And the reason we multiply the whole thing is because this came from one guess, right? So it'll be yp equals ax to the 4th plus bx cubed plus cx squared plus dx e to the x, right? E to the x. Let's do another one. I think I'm gonna make one up. A, B, C, D, E, F, G, H, I, J. One more. Let's see, YC. Let's do a sine and cosine. Let's see, C1 cosine x plus C2 sine x. Okay. And let's say that our g of x here is just x sine x. This one's pretty tricky. All right, so our initial is based solely on the right-hand side of the dE. So in this case, our initial, well, it's got a sine, so you have to have the sine and cosine, right? But it's got an x, so you have to have the full linear in front of each. So it'd be ax plus b sine x plus cx plus d cosine x. So that would be the initial guess in this case. Now for the modified, right, we have to look only at the terms of yc and at our yp. So you might say, well, there's no repetition, but no, yes there is. Look, b sine x repeats with sine x, and d cosine x repeats with cosine x. So we have to multiply the whole thing by x. So yp would be ax squared plus bx sine x plus cx squared plus dx cosine x. And that would be our modified. Well, I just realized this video has gone 14 minutes. I guess we'll stop here. I hope this helped. That's it.